Try to explain from a macroeconomy point of view why energy is not well taken into account in most of the macroeconomy models. And the floor is yours.
Thank you. I'll try to even a little bit more than that. I will try to discuss with you some criteria that should be fulfilled by a good economic model with the aim to couple this model with a physical model. Since at the end of the day, this is what most of us want to do. You have an economic model that makes sense in order to let it work together with some engineering or physical model. And then I'm just going to focus on the economic part and to ask a few questions and to list a number of properties that should be satisfied by a good model. And then we can discuss about it, if you don't agree. Is that clear? So the first part, I will recall some background material on the neoclassical models. Then I will focus on the demand side, then the supply side, and then matching demand and supply. Okay? So some background material. I don't know whether you realized it this morning, but 99% of the neoclassical models assume that the households in an economy, they do one job, they maximize their utility function over there. What is utility? Nobody knows, okay? It's a kind of abstract measure of the felicity of people, of whether they are satisfied or not. Here, just for the aim of this presentation, I assume that it depends upon your consumption today, your labor today, consumption tomorrow, labor tomorrow, etc. until the end of your life. You try to maximize this, that is, you choose the amount of oranges you want to eat every day, the number of hours you want to work, or whether you want to go on holidays, these for today and all the days in the future. And you have a budget constraint, which is that at every time t, your expenditure cannot exceed your wealth. Your wealth is given by the amount of labor you work times the wage, and this is your demand, the consumption times the price. Okay? And here it's a scalar product because you may have, this is a vector, this is a vector. Okay, this is assumed to be a real number, and this also.
There's no credit in the number.
There is a credit. Okay, I could add credit. There is no credit here for simplicity, but there could be credit.
And no revenues from capital.
Just for the presentation, there is no income from capital, but you could add it. No problem. It's not an issue. What is an issue is that, well, just an example of a typical utility function that people use. What is an issue is that in order to solve this problem, you need to know the price tomorrow, after tomorrow, 3 days after tomorrow, etc., for all your consumption goods. So you need to know the price of oil in 10 years with a perfect accuracy. Okay? So in other words, you need to have rational expectations. This is the way economists think of it. So they assume that people know perfectly the series of prices of all the consumption goods, and okay, they might consume from now until the end of the life. For instance, in the presentation this morning from Mr. Leautier, this was implicit. Okay? Of course, economists don't like to put emphasis on this, especially when they talk to physicists, because they know that this is just a crazy assumption, but this is an assumption pertaining to 99% of all these neoclassical models. Okay? Now, what does the firm? The firm tries to maximize its profit, its discounted profit. So here you find the discount factor that was mentioned this morning. The price times what? The output minus the input. Okay? So this is what you will sell on the market. This is the cost. Okay? PT times this is the cost. And you try to maximize the cash flow from today until the end of your life. So again, you need to have rational expectations. You need to know perfectly all the prices of all the production factors from today until the end of your life. And there is a constraint, which is a technological constraint, and that's here. Your output cannot exceed the maximum amount of output you can produce given your input. And this is the production function that was mentioned by Rainer and Cédric a couple of minutes ago. Okay?
This production function assumes that the economy works at full capacity.
Yeah, for simplicity. Yeah, for simplicity. Okay. An example again, now you're familiar with it, the Kabul-Glass production function. So all these production functions are smooth functions. They assume a kind of substitutability across production factors. Okay. There is no path dependence of the production. Okay. And usually you have decreasing returns to scale. This was discussed earlier. Okay. So question, perfect foresight, does it make sense? My answer is no, certainly not. So I don't see the relevance of any model, any economic model that relies heavily on the assumption of rational expectations. So my first criterion is a good model should be a model where you don't make the assumption of rational expectations. Of course, by saying this, I know that 99% of the neoclassical models are disqualified, or maybe 90%. Okay, we can discuss about it. Equilibrium in this kind of model is a fixed point, because at the end of the day, what you do is you compute, wait a minute, you compute the solution of this maximization program, and this leads to the supply of consumption goods. You compute the solution of this maximization program, and this leads to the demand of consumption goods. And then you try to find a fixed point, namely a price that is such that the aggregate demand will be equal to the aggregate supply at each time, t. Okay, this is a fixed point problem. Sorry. So it means that it's an entirely static theory where the past is equal to the present is equal to the future. Okay? So remember this morning, my colleague Léautier said we have a dynamic theory, but it's cheating because it's not a dynamic theory. It's an entirely static theory where you have time, but the fact that you have time does not mean it's dynamic. Okay? So these are entirely static models where you don't have any uncertainty on prices. Prices are perfectly known by everybody. And also, I mentioned this before of the talk of this morning, there is a big difference between risk and uncertainty. And if you are not careful, there is a shift of words between risk and uncertainty. What people understand under the word risk is if I flip a coin, I don't know ex ante the result, but I know the probability of the result. Okay? I know that with probability 1/6, I will have this and this. Okay? Uncertainty, I don't know the result. If I flip a coin, 1/2. Okay, sorry. If I flip a dice, I was thinking about the dice. Okay. Uncertainty, I don't know the result and I don't know the probability. Okay? Question, do you think that we know at least the probability that the price of a barrel of oil will be above $300 in 10 years? I don't think we even know the probability. Okay? So the right framework should be uncertainty, and in most of these models it's risk. Okay? Yeah.
Sorry to interrupt, but shouldn't we speak about indetermination instead of uncertainty?
If you want. If you want. Yes, why not? I mean, this is just the standard word used by economists. Okay? Just an example, impulse response function. In most of DSG models, that is dynamic stochastic general equilibrium models, which is kind of basic tool used by many economists, what you do is you look at a fixed point, which is an equilibrium, you make a small perturbation of one parameter, and you look at the impulse response function, the way the system goes back to the equilibrium, at which speed and how, etc. You see that this is an entirely static theory, although you may have beautiful pictures with movements, but okay, since you are physicists, you understand this. Another point which is very important, the budget constraint is usually zero homogeneous, which means if I multiply prices and wages by 2, it doesn't change anything. You realize this here, okay? Everybody agrees? If I multiply prices and wages by 2, this is the constraint, remember, this is the budget constraint. It doesn't change the budget constraint, therefore it doesn't change the maximization program, therefore it doesn't change the solution, okay? It has no impact, okay? Which means, okay, this is a mistake, which means that there is no money in this model. You understand this? Okay, I repeat, this kind of model is unable to provide you with an equilibrium where you determine the level of prices.
But that's because you forgot about credits.
Okay, I could add, okay, I could add credit, nevertheless do it in a way such that everything remains zero homogeneous. And this is usually the way neoclassical models work. Okay? My point is, even though you may have a model, an economic model, where you have an interest rate, people speak about inflation, okay? Most of these models are models where there is no money, in the sense that they are not able to determine at equilibrium the absolute level of prices. All they can do is to determine the relative prices between, let's say, oil and coal, but they are unable to tell you the absolute level of prices of the price of oil, for instance. You see what I mean? So, for instance, the models you saw this morning are models with no money. So it's a bit paradoxical to speak about all these questions with models using no money. You understand my point? These are purely real models where people trade oranges against apples, and there is a unit of account, okay, which is the unit in which this is expressed, but this is not money. Yes, and this is a very important point, because I know every time I ask the question, where is money in your model? Then it's a bit disturbing. So the criterion is very easy. Even if you don't know anything from economics, just check whether all the constraints are zero homogeneous, then you are sure there is no money in the model. Okay? So believe it or not, this is the core of mainstream economic theory. So I don't have time enough to go into history, but so this is a quotation by Olivier Blanchard. Olivier Blanchard, as you know, is the chief economist of the IMF, a French guy. So this is what he wrote in 2009, so after the crash of 2008. The most visible outcomes of this new approach are the dynamic stochastic general equilibrium models, DSG models, that I just mentioned, okay? Entirely static models with no money. They are models derived from macro foundations, that is, utility maximization by consumers, workers, this we saw, value maximization by firms, rational expectations, and a full specification of imperfections from nominal rigidities to some of the imperfections discussed above in the paper, and typically estimated by Bayesian methods. So this last part of the sentence is now the part of these models on which most economists focus, that is the frictions, okay? So we have a model, and they focus on the frictions. Frictions.
What sort of friction?
Nominal rigidities, etc. For instance, imperfections, frictions, okay? But then a question I ask, if you start with a very wrong model, what's the use of adding frictions? Okay? If you start with a model with rational expectations and no money, you can add imperfections, doesn't change anything. Okay? And still in the same paper, 2009, the state of macro is good, he said. Macroeconomics. Okay? Even 1 year after the crash.
Not from the World Bank?
No, IMF.
IMF, yeah. So the boss of Kumhoff.
Yeah, exactly. He's the boss of Kumhoff. Exactly.
Poor Kumhoff.
So now 2 years after the crash, he wrote, identifying the flaws of existing policy is relatively easy. It's his opinion. Defining a new macroeconomic policy framework is much harder. This I agree. It is important to start by stating the obvious, namely that the baby should not be thrown out of the bathwater. Most of the elements of the pre-crisis consensus, including the major conclusions from macroeconomics theory, still hold. Okay?
Whistling in the dark.
Okay, no comment. Now, second part, the demand side, the law of demand. So you heard it also this morning, a huge part of these models, not all these models, but a huge part of these models, start with a representative household. That is, they assume that everything goes as if we could summarize the behavior of all the households into the behavior of a single household. Okay? The main problem by doing this is that you don't have any distribution issue. So the kind of exercise that was presented to you by Sandra and Jacques is impossible. Because in the economy there is a single household. So they are not poor and rich people, there is just a single household. You get it? So by doing this, of course, if you ask, for instance, this morning, remember, my colleague and friends said, you have to realize that if you want to do this kind of exercise, you need the representative assumption, because otherwise it's very complicated. Okay? But then the question is, of course you like to do this assumption, maybe because it helps you not to talk about distribution issues. Okay? Question. In addition to that, there is a famous result by Sonnenschein, Mantel, and Debreu in the 70s, so neoclassical economists, which shows that if you consider the solution of this maximization program I just mentioned of the consumer, you add it, then you end up with the aggregate demand, and it turns out that the aggregate demand can be any continuous vector field on the unit sphere of prices with some boundary conditions. In other words, at the aggregate level, the demand can be anything. In particular, this proves that it's wrong to assume that we have the law of demand at the aggregate level. The law of demand saying that if prices increase, then the demand will decrease. This is true at the individual level. Being a household, if the price of something I like increases, I will demand less of this good. But at the aggregate level, it's not true, in general. In general, yeah. And maybe you remember, or you can check on the video, this morning it was repeated several times. Don't forget, if the prices increase, then the aggregate demand will decrease. So this is just wrong because of this theorem, which is a neoclassical theorem. So here sorry?
I thought the statement is wrong, but the assumption is wrong. Is that the...
I mean, yeah, it's an assumption which is contradicted by a theorem within this theory. Okay? So now you discover another thing, another characteristic of my profession, which is that some people discover some, non-comfortable results, and then the whole profession forgets them. Okay? Okay? You get it? For instance, you remember the first Greek guy who discovered that there may be non-rational numbers. I don't remember his name. But there is a Greek mathematician who made the first proof that square of 2 is not a rational number. Okay? Then he was killed. Because at this time, Pythagorean people wanted to be sure that there were only rational numbers. Okay?
He
So
got the Nobel Prize.
yeah, this guy got the Nobel Prize. Yes, you're right. But not for having proven this. Okay? So we economists, we do it the other way. We don't kill people who... We kill the result. We forget the result. Okay? Which, from my point of view, is worse. Because we know now in mathematics that there are irrational numbers, although we forgot the name of this poor guy. Okay? But nowadays, economists forget this. So another point is that, from my point of view, economic models should not rely on the law of demand at the aggregate level. Okay? Even though I know this is quite disturbing. Okay? This result, from the point of view of physicists, can be interpreted as a scale transition result, like in statistical physics. What happens at the microeconomic level need not imply anything meaningless for the macroeconomic level. You may have phenomena at the macroeconomic level that you never see at the microeconomic level. Okay?
So it belongs to the realm of emergence?
Yeah, emergence. Yeah, exactly.
I don't understand this sentence. Vector field or unit field, the boundary condition. Is the graphical representation possible of this?
Sorry?
I don't understand the sentence. Vector
Yeah.
field on the unit sphere with boundary condition. Is the graphical representation possible?
Yeah, I can show you. Yeah, sure. So you remember the budget constraint, which is, to simplify, suppose it's something like this. Okay, this is what I consume, this is what I have, labor or whatever. This is the price, and this is my budget constraint. Okay? And I maximize something which depends upon this. Okay? This was my maximization program. This is just a budget constraint, remember. I wrote it this way, but it's the same. Okay? Yes? Okay? So I decide to write it this way, which, as far as I know, is entirely equivalent. If u is a strictly increasing function, it's not difficult to see that at the solution you will bind the constraint. Okay? Trust me. So this means that this is orthogonal to P. Okay? P is the price. This is your excess demand, your net demand. Demand minus what you get. Okay? Now, as I told you, the absolute level of price is indeterminate in this theory. So I decide to normalize the price by its norm. Now this belongs to the unit sphere. Okay? And now I have a vector field, which is this vector field, orthogonal to P, on the sphere.
So
You get it?
the axes are spanned by
The axis?
the different numbers of households.
No. The axes are spanned by the. This is of dimension 3 in this example. Okay? This is in R3. There are oranges, apples, and bananas, and potatoes. Okay? So P is a vector in R3. Okay? You get it?
No, I don't understand the vector axis.
Okay, maybe we don't have time enough to. I can explain it during the dinner.
Three
Okay?
goods or that goods?
Three goods, yeah, goods,
So
commodities.
if you have n goods, you have an n dimension.
Sure,
Right.
sure.
Okay.
Sure. What I'm saying is that the net demand is orthogonal to the price. The price is normalized in the unit sphere, so you have a vector field. And the beautiful result says that this vector field could be any vector field, provided it is continuous and it is inward pointing on the boundary. Okay? Okay? So especially it has no reason to satisfy the law of demand.
What would be the law of demand in that account?
The law of demand would be if the price of one commodity, the relative price of one commodity with respect to another increases, then the demand decreases. Okay? So this would make a special property of the vector field. Okay?
So the vectors are not tangent. They have a normal component.
No, the vector are tangent because this is the excess demand in all the commodities. So it would point in the direction of the commodities which is cheaper.
And the parameter then on the sphere is homogeneous, is constant or so?
Sorry?
The parameter itself, or is it, I don't know.
Which parameter?
Yeah, whatever now you identify, each point has sort of a parameter. You
So
can
this
say
point-
something like this, yes.
This point is a price.
And it has an absolute value. And is the absolute value distributed constantly on the sphere? Or is this not an issue?
Which absolute value? You mean this?
Yeah, for example.
This is equal to 0 because it's a vector field. It's tangent to the sphere.
It's known.
Yeah. Let's see it this way. I'm sorry to spend time on this, but
Don't do it, please.
okay. No. I just okay.
It's a homework problem.
Yeah. Can see it this way. Okay. This is the price P, and this is x minus e. Okay.
But now okay, we can discuss that.
Okay.
We take a blackboard at the restaurant.
Okay. Incomplete markets. A good model should be a model where there are financial markets, because finance plays a tremendously important role today in macroeconomics, and markets should definitely be incomplete. I already talked about this 2 days ago, so I don't spend time on this. But you remember that if markets are incomplete, there is a strong inefficiency of the equilibria, so most economists don't like this. Okay? And one word about debts, private debts. There should be private debts, because private debts, as you know, play a very important role today. Let me just show you this example. These are debts in the Eurozone. This is the debts of households, private debt of households. Public debt, debt of private non-financial corporates, debt of financial corporates. So if you believe that we should reduce our debt in Europe today, you should begin with the worst case, which are banks, not the state. Okay? Okay, I go back to my point. Private debts. Definitely private debts are important, and unfortunately there are still macroeconomic models today where people don't have any debt. There is an example, a paper by my friend and colleague Benassi-Kéré and Fontanier from 2012, where they predict that Japan should take off at this time in 2 years, that is this year. And the GDP per capita of Japan should rise and go at the same level as the GDP per capita of the US. So I was fascinated and I thought, but how comes they can say something like that? Japan is in the deflationary trap since 20 years and struggles against it with no success. How can they say that in 2 years it will take off? Then I looked at the model and I talked to Agnès, and then we realized that Japan had no debt in the model. So of course, if people don't have any debt, it's clear that Japan tomorrow morning will take off. Okay? But what's the use of a model where people don't have debt? Okay? Another a nice paper by Krugman, who got the Nobel Prize. But you know, economists, they need to mention it as an authoritative argument. Okay? Krugman and Egerton, so they published a paper where people have debts. From my point of view, it's the first DSG model with debts. But there is still no money. It's still a barter economy. You have debts, but my debt is in oranges. It's not in money. Okay? So a good economic model should have heterogeneous households in order to be able to talk about the kind of questions that was mentioned by Jacques and Sandra. Incomplete markets, private debts, not involve the law of demand, have money. Check presence of money, I already said. Okay. One word in addition to that, money should not be neutral in the short run. What does it mean that money is neutral? It means that if you just multiply the quantity of money by 2, say, it has no impact, but it just multiplies the level of prices by 2. But unemployment, everything else remains the same. So the real economy is the same, and money is just as if you were changing the unit in which you measure the temperature. Okay? But the reality does not change. Okay? So there are big debates among economists upon whether money is neutral. All the empirical investigations show that in the short run, money is never neutral. Never. So a good model, economic model, should necessarily not assume that money is neutral in the short run. Otherwise, it's at odds with empiric. Okay? Now, question. Is money neutral in the long run? First of all, Keynes, as he said, in the long run, we're all dead. So what's the use of asking this question? And second, we can never observe long run. Because all the economists say, well, you know, we didn't wait enough. Just wait a couple of years more and you will see that it's neutral. Okay? So saying, you should be careful about that. When economists say, I assume something to be true in the long run, it means that it cannot be tested empirically. Because we can never wait long enough to see whether it's true. Okay? So saying that money is neutral in the long run is a kind of metaphysical statement. Okay? It's not science, from my point of view. Okay? So the model should not involve the money multiplier, but I already debunked the money multiplier 2 days ago, so I don't spend time on it. Banking credit. There should definitely banking credit in the model, but this is also very disturbing. E equal to S is probably the most famous equation for economists. This is investment, okay, and this is saving. So in 99% of these models, you have investment equal to saving. But if you understand that there is banking credit, investment should be equal to saving plus credit, money creation. This means that this equality is wrong. Okay? So a good model should be a model where you have this kind of equality and certainly not this kind of equality. Okay? Deflation should be possible in the model. Deflation is what you see in Japan for 20 years. What we may have in the coming years in Europe, that is a situation where the economy is trapped with no inflation, no growth, unemployment, and a huge number of debts. An example, it's Japan. So this is Japan, because Japan has, had a financial crisis at the beginning of the 90s. Since then, the interest rate of the central bank is 0. The real GDP, has no growth anymore. And Maybe you have prices here. So this is the price level in Japan since 1998. So this is deflation, okay? Then a good model should allow for this. If you have a model where deflation is impossible, then you should question the model. And maybe you understand why there is a big debate today between people like Philippe Aghion, yes, Aghion, Hashimoto, I'm sorry for the name, because, and someone like Krugman, because these economists, they work with models where deflation is impossible to begin with. So Aghion, for instance, says, you should not take care of deflation in Europe, because in my model, I don't see deflation. Then my answer is you should change the model, okay? He wants to change Europe, which is different, okay? On financial markets, speculative bubbles should be possible. A speculative bubble is not something completely irrational. You may have speculative bubbles within an entirely rational model. It just means that the price of an asset is not equal to the discounted cash flow, to the discounted sum of its cash flows. And this is perfectly compatible with rationality. But you have many models where it's impossible. Crashes should be possible. If you have a model where there is a priori no crash, so you should question the model. At least this is my opinion. And this is possible. There is a literature within the general equilibrium theory, starting with Bill Zame in 1990, and to which I myself contributed, where you may have crashes at equilibrium. Even in these stupid neoclassical models, you may have crashes. Okay? Just to remind you.
What is the definition of a crash then?
The depends upon a model. Here in my model, a crash is a situation where nobody trades because everybody is bankrupt.
Well, nobody trades.
Because everybody is bankrupt. Okay? Just to remind you, this is the Dow Jones. This is the Dow Jones. Okay? Here you see the dot-com bubble, subprime bubble. Okay?
And the next one.
And the next one. So bubbles do exist in real life.
That's money on the day.
Yeah, we should divide by inflation. Okay? Just to okay. You may remember that something happened in 1929. Okay? Just to make sure that something happened, this is a zoom of what happened in 1999. Okay? So a model should have crashes, should allow for the possibility of crashes. Okay? Bubbles. This is for the housing market because we talked about it yesterday. So this is the nominal price of housing in the US, the real price of housing in the US. So you see, let's consider just the real price that is divided by the inflation, okay, corrected by inflation. The real price of housing from 1995 until 2005 was multiplied by 2. Okay? Okay? And do you think that within 10 years, the real value of houses were multiplied by 2? Certainly not. So this must be a bubble, okay? Which can be perfectly explained, so I don't have time enough to do this now. But a good model should allow for this kind of phenomenon, okay? Now, one word about something very controversial. The marginal productivity doctrine should not be used. This is my viewpoint, and I know that a lot of people will disagree with that. All the discussion we had just now with Reiner's result, that the marginal cost, the cost share theorem is wrong, says the same. Most of the neoclassical models, they start with the maximization programs I just described. They compute the first order conditions of these maximization programs, and then they derive from this some conditions. Okay? One of these conditions is that, for instance, at equilibrium, people should be paid according to the marginal productivity. Okay? This is why we had this discussion 30 minutes ago. Now, an example. So this is productivity in the Eurozone, labor productivity, and real wages. So do you really think that people are paid according to their labor productivity? Maybe you could say, well, this is just specific to the Eurozone. This is in Japan. And this is in the US. So in the US, we were at equilibrium somewhere here, roughly speaking. So I'm a little bit, I go very fast, but we can discuss about it if you want.
Did you get
Yes, wait a minute. So I skip this, the supply side. An important point also, you remember that the presentation of production function that we had earlier, and we made the assumption that, remember, alpha plus beta plus gamma is equal to 1. Remember that? So this amounts to saying that the production...
Fixed point of time, at a fixed point in time.
At a fixed point in time. Okay.
Fixed point in
Yeah. Sure. Okay? No, I agree. Then, nevertheless, I ask the question, are we sure that the global returns to scale are decreasing or constant? Constant, they are equal to 1. Decreasing, they are less, they are smaller than 1 in the industrial sector. I know just a few empirical investigations on this issue, and the few I know are negative. In the industrial sector, I'm not sure at all that this is true. It's a question I ask, okay? Now we should be careful because there were a lot of econometric estimations of this at the macro level, and they all conclude that this is equal to 1. But there were also proofs, very old, already in the 50s, that this is just an accounting artifact. It does not mean that the real production function of an industrial sector has constant returns to scale. So this is a tricky topic, and I'm just mentioning this topic. We need more investigation on this issue. Okay? Probably we should take into account that with respect to energy, we have decreasing returns for physical reasons. Okay? Entropy and so on. Okay? Why do most economists favor global decreasing? And most of the economists, they don't even do what Rainer did. They assume that this is strictly lower than 1. Okay? Why? Because if you assume the opposite, if you assume this, then the neoclassical models have a lot of problems. First of all, profit maximization may not have any solution. You have a non-convex problem, maximization problem, which may not have any solution. And the usual standard answer to this is that then we should nationalize this firm. Okay? But then this means if it were true that most of the industrial sector have increasing returns to scale, that is something which is larger than or equal to 1, then we should have a huge public sector. And this is not the kind of conclusion that most neoclassical economists want to have at the end of the day. Okay? And the solo macroeconomic model, which is the workhorse growth model invented in the 50s, would not even have any stationary point. So there would not even be an equilibrium in the most standard growth model if you had global increasing returns. So even in the model of Rainer, where you have here constant returns to scale, these people have a lot of problems. Well, and my guess is that this is why they favor decreasing returns, strictly decreasing returns, without having investigated seriously whether this is true. Okay? Okay, I don't have time. So this we saw at length. So this is the output elasticity of energy. So I'm going to repeat what was already said. So I'm going to skip this. Just Blanchard, my friend Blanchard that I already quoted, every 3 years he publishes a paper to say, well, you know, don't worry about oil. Oil is not a problem. Why? Because in my model, in his model, the output elasticity of oil, thanks to the cost-share theorem, is very, very small. So, and then he says we could have a fourth or a third oil shock and without being very hurt in our economy. Why? Because the elasticity of energy is so low in his model. Okay? So here you have the cost share of energy in the US. So it's a little bit more than 5%, but it's between 8 and 14%. But anyway, it's very low. Okay? Then, so I quote, of course, Rainer works on this, and I want to quote a work with Zeynep. So we did some econometrics. Actually, Zeynep did some econometrics to check this elasticity, and we found 0.6, as you did, Rainer, for energy. Okay? 0.6. Okay? So 0.6, and David Stern, not Nicholas Stern, David Stern, did the same work and found the same answer. So empirically speaking, the output elasticity of energy is around 0.6, 0.5, 0.7, depending upon the country. Certainly not 5%. Okay?
that's a quite independent model you are using
Yeah.
to obtain the same result.
Yeah, exactly.
So that's fine.
And I also did a counter test. I also made a Bayesian estimation of a DSG model, a neoclassical model, where I find again the same elasticity. So it's a quite robust result. So question, why do so many economists stick to the Kostya theorem? Well, because if you see this, then you understand that capital accumulation is not the predominant root of growth. It's not capital accumulation, it's energy. But then you're against Marxian economists and against neoclassical economists. Okay? Because both of them, they agree on the fact that capital is the unique. So a good model should not rely on the Kostya theorem.
Can you come back on this last sentence?
Yeah.
What do you call capital? Physical?
No, it's productive capital.
No, it's different from capital, financial capital.
There is no financial capital here. Sure. It's
Real
product.
capital.
It's a real capital in the same sense as the Rainer. But for instance, for the Bayesian estimation of the DSG model, I did the same exercise with the enlarged definition of capital by Piketty, and I found the same 0.6, 0.5 elasticity for energy.
Excuse me. What is the Granger causality test?
Oh yeah, sorry, I forgot to say this. Thank you. You might know also that there is a big debate regarding whether, I mean, if you see growth of GDP, you will see a growth of the energy consumption. But then you might say, this is not because energy causes growth. This is because you cannot have growth without energy. So question, it's a chicken and egg problem. Is it growth that induces an increase of the consumption of energy, or an increase of consumption of energy that causes growth? And Zeynep did the test, the Granger causality test, which is an econometric test, and the answer is unequivocal. It's energy that causes GDP. Okay?
For 15 countries that we use.
For?
For the 15 countries.
Yeah, okay. For the couple of countries, for a certain period of time, of course. Okay, I don't have time enough to... No, but you're right. Yeah, then a good model should certainly add physical constraint to the production function, hence the use of the Linux production function by Rainer. Okay, this already said. A word about the substitutability among factors. This is also an issue. My viewpoint is that ex post, the production factors are not substitutable, ex post. Once you have built your factory, you cannot transform your factory into labor force or into energy. Okay? Ex ante, before building the factory, you have a choice regarding the amount of capital, the amount of labor, the amount of energy you will put in your factory, but once it's built, it's done. Okay? So ex post, the production factors are no more substitutable. So this is not that easy to include into a model. So there is another issue, which is, what about the stock of past capital? Let me say it another way, but it's the same problem. If you have millions of cars that run with fuel, it's not that easy to transform them from one day to another into cars with electricity. So even if you can build cars with electricity today, you are stuck with a huge stock of capital of bad cars, okay, if you can say so. And this should also be taken into account. So my suggestion is that we should use particular technology, okay, which is a kind of way, it's a more sophisticated way to formalize the production function, where ex ante, you may have, let's say, Linux production function, a la Rainer, and ex post, you have a Leontiev production function, because ex post, production factors are no more substitutable, okay? And then this would allow you to speak about generations of capital and to have a path dependence of the model, despite the fact that you use production function, okay? You may have a path dependence of the model, saying the way the investment you did 10 years ago, they play a role today.
But then you don't have a state function anymore.
Then it's not that easy. If you want to write it as a state function, you need to write as a parameter of the state function the whole path, as I said you, okay? Then you are in an infinite dimensional space, etc. Okay? My personal viewpoint on technological progress, I'm very conservative. What do I mean with this? Exogenous technological progress, which was introduced by Giraud, Solow, etc., was invented to fill the gap of the solar residual that was mentioned by Rainer. I don't know whether you got this. I mean, if you try to check whether the standard growth model works, you will find that it fails to explain 2/3 of growth, 60% at least of growth. Then when people realized this in the 50s, 60s, then they said, okay, let's call this residual technical progress, and then we have it. Okay? And then, of course, technical progress is just a word to explain what economists can't explain. Okay?
Also called manna from heaven.
Manna from heaven, exactly.
Yeah, maybe you want to address the last matching demand and supply.
Okay, yeah. Matching demand and supply, exactly. The model should be able to exhibit cycles. Because in real life, we do have cycles, okay? Bearish and bullish phases. Of course, if you have an entirely static model, you cannot have it, okay? So you should be able to have cycles. Yeah, so the model should, okay, this I already said. The velocity of money, if you have money, first of all, you should have money in your model. Second, if you have money, the velocity of money should not be constant. An example, the velocity of money in France from 50 until today is certainly not constant. Okay? So this is a minor detail for specialists. A good model should also allow for unemployment, because there is unemployment. Okay? If you think about it, you will see that in many models, there is never unemployment at equilibrium unless you have frictions. So the unique reason why you have underemployment in economy in these models is because, let's say, you have a minimum wage, which is a friction. Okay? And then you have these economists who will say, I'm mentioning this point because I know it's a hot debate in Germany today. These economists will say, well, if you have a lot of underemployment, this is because you have a minimum wage. Okay? Because in their models, where all prices and wages are perfectly flexible, you would never have underemployment by construction.
Yes, in the slavery stages of history, of course, you have no underemployment.
I agree with you. So this is a question I ask. Okay. Then, having said all this, you could say, well, your ideal model does not exist. And my answer is, unfortunately, yes, not yet. But we are working on it. So this is just a small example to convince you that it's possible to go forward in the right direction. So it's a very, very small example. It's a three-dimensional dynamical system, non-linear dynamical system, where you have depths. So you have a dynamics for depths. This is employment rate, and this is the wage rate on GDP. If you don't have depth, you have a perfectly conservative model where you see that employment goes from 70% until 95%.
What is omega?
And omega is wage share, so the share of wages in the GDP.
Okay.
As you heard this afternoon, empirically it's approximately 70%. So, of course, this is not entirely realistic, okay? But it's just to see that it's possible to build such a model. And if you look at growth in the version where there is no depth, then you have cycles and you have growth. Okay, very simple model, two-dimensional. Of course, you never see this kind of figure in a DSG model, neoclassical DSG model. It's absolutely impossible because these are static models. Okay. Now, if you add the third differential equation with depth, you may have this. This is the output. And so you have the economy is overwhelmed by debt, and here you have a crash. So it is possible to write down very simple models, dynamical models with crashes, debts. So what we need here is to add money, because there is still no money here, okay? To add the Linux projection function or whatever, a good and a clever projection function, etc., etc. But it's possible to work in the right direction. Okay, and just wait a minute. This, I don't have time enough to say this. Yeah, just to conclude this comment. From my point of view, we should carefully distinguish between the three kind of constraints in our scenarios and in our models. There are physical constraints like the second law of thermodynamics. We cannot play with them, okay? They are mandatory, okay? No problem with that. There are behavioral assumptions. For instance, when we assume that people will agree to reduce the consumption of energy at the level of 20% in 10 years. But this does not have the same status as physical laws, okay? Maybe we can discuss about this, the second kind of constraint, not about the first kind. And there is a third kind of constraint, the institutional environments, the legal framework, how the banking sector works, etc. And with this, we can also play. And from my point of view, it's much easier to play with the third constraint, because this is a political issue, than with the second, and a fortiori than with the first. Okay? So, thank you.